Hello everybody, today we're going to talk about proving quadrilaterals. The first thing I want to do is I want us to review what kinds of formulas we know and how they can help us prove quadrilaterals to be specific shapes. The first thing we know is the distance formula. The distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. We learned this in the beginning of the first trimester. And we can use the distance formula to determine whether segments are congruent, whether a segment is bisected, or to determine the length of diagonals. We also know the midpoint formula, which is the average of the x's and the average of the y's. And we can use this to determine if a segment is bisected or to find the midpoint of a segment. Then we know the slope formula, and of course there are many versions of the slope formula: rise over run, change in y over change in x, y1 minus y2 over x1 minus x2. And this helps us determine if two segments are parallel, meaning they have the same slope, or if two segments are perpendicular, meaning they have opposite reciprocal slopes. Now let's see how we might use these ideas to help us classify a triangle as either equilateral, isosceles, or scaling. The first thing I'm always going to do is plot the points they give me. So I've got triangle ABC, and I have even labeled the opposite sides. Now, in order to know if it is equilateral, isosceles, or scaling, I want to find the length of each side. Because equilateral means all sides are equal, isosceles means two sides are equal, and scaling means no sides are equal. So the distance of segment C, that is the segment connecting point A to point B, I just plug in the points into the distance formula. I get that the length of C is 5. I do the same thing for A. I also get 5. And the same thing for side B. I get 5 square root of 2. Because of this, I can determine that triangle ABC must be isosceles because the two sides are congruent. Now, I want to see if I can classify this triangle as either a right triangle or a non-right triangle. I know that a triangle will be a right triangle if two sides are perpendicular to each other. I can determine if something is perpendicular by using the slope of each side. So I went through and I found the slope of each segment. The first one, for the slope of A, I used the general slope formula. Same thing for the slope of line B. Then I looked at the rise over run for line C, and I ended up getting the following numbers. Now, I can see that the slope of A is -4/3. The slope of C is 3/4. Those are opposite reciprocal slopes. So triangle ABC is a right triangle because the segments A and C are perpendicular to each other. Now, if I want to prove a shape to be a quadrilateral, there are 6 different ways I can prove it. The first is to prove that both pairs of opposite sides are congruent, or to prove that both pairs of opposite sides are parallel, or to prove that an angle of a quadrilateral is supplementary to both of its consecutive angles, or to prove both pairs of opposite angles to be congruent. We can also prove that the diagonals of the quadrilateral bisect each other and that one pair of opposite sides are both parallel and congruent. So you have 6 different methods to prove something to be a parallelogram. Now I'm going to go through these 6 examples and see whether or not they're all parallelograms. Number 1, it shows that one pair of opposite sides are both parallel and congruent. So yes, it is a parallelogram. Number 2, I see that the diagonals bisect each other. So yes, that is a parallelogram. Number 3, I see that opposite sides are congruent, so it is a parallelogram. Now number 4, I've got that one pair of opposite sides are congruent and one pair of opposite sides are parallel, but they're not the same segment. So no, I cannot prove that to be a parallelogram. And 5, I can't immediately prove that to be a parallelogram, but I can take steps to prove that the third angle in each of the 2 triangles that diagonal has created would be congruent. Therefore, this would be a parallelogram because the opposite angles are congruent. And in number 6, I see that the angle 120, it is supplementary to both of its adjacent angles. So yes, that is a parallelogram. Let's look at some more practice. With this picture, if I know that E is the midpoint of AC and BD, I can prove that this is a parallelogram because both diagonals are bisected. If I know that the measure of ABC and the measure of BDC are supplementary, I actually need more information to prove that that's a parallelogram. I need both angles that one angle is adjacent to in order to prove that's a parallelogram. So no, I can't do that. AB is parallel to DC and BC equals DA. Again, we're talking about two different pairs of segments. So no, I need to know that one pair is both parallel and congruent. Now we have a very short proof. I want to prove that ABCD is a parallelogram, and I'm going to start off by drawing one diagonal. And I can do that because of the definition of diagonal. Then I list my givens. They give me that the opposite sides are congruent. And then I'm going to add in that AC equals AC. Well, that's the reflexive property that we talked about a couple of sections ago. Now, I can prove that triangle ABC is congruent to triangle CDA by the side-side-side triangle property that we learned about in the triangle section. Therefore, angle B must be congruent to angle D by CPCTC. Now, I'm going to switch diagonals and do this exact same process again, but for the other half of the parallelogram. I'm going to draw a diagonal from D to B, take away the one from A to C, and I know that BD is congruent to BD by reflexive property. Therefore, triangle BCD is congruent to triangle DAB by side-side-side. Therefore, angle A must be congruent to angle C by CPCTC. Now, I have that opposite angles are congruent in this parallelogram. Therefore, ABCD is a parallelogram because both pairs of opposite angles are congruent. Now, if I want to prove something to be a rhombus, I first have to prove that it's a parallelogram. Then once I know that it's a parallelogram, I can prove that a parallelogram is a rhombus using three methods. I can prove that the diagonals of a parallelogram are perpendicular. I can prove that one diagonal bisects a pair of opposite angles. Or I can prove that all four sides of a parallelogram are congruent. That's our definition of a rhombus. Now, these are some unusual examples, and it just uses the properties of rhombi to help us complete them. Here, they give me, in this first example, A, B, C, and D, where I know points A and B. I know A is at 0, 0, and B is at A, comma, B. Well, I know that the height of this must be B, so the y value of C must also be B. Now, in order to solve this problem, I'm going to draw a right triangle by drawing a height from B to the x-axis. I'm going to redraw the triangle up here. Now, I know that we have gone A across and B up on this right triangle. I can now get the side length of this rhombus by using the Pythagorean theorem. C squared equals A squared plus B squared, therefore C must equal the square root of A squared plus B squared. That is the length of any side of that triangle. So I know that the x value for D must be the square root of A squared plus B squared, because D is the equivalent of the length of one side. Now, point C, the x value is square root of A squared plus B squared, but I have to add an A to it because we're already shifted A over on the top. So we have now found all of the coordinates of this example. Now let's look at the next one. Here they give me A is 0, 0, and D is A, comma 0. Therefore, I immediately know that the length of my parallelogram, each side must be a length of A for this rhombus. Now I'm going to do like I did before and draw on a height. I'm going to redraw up above. I know that the side length is A, so we can put that on the diagonal. I also know that we have gone across B because I know that the x value of point B is B. Now I can use the Pythagorean theorem to find the height. Now I have done it with other variables so that we don't get confused and then plugged in at the end. So I know that my height of this must be a squared minus b squared, square root of a squared minus b squared. That is the y value for both b and c. Now all I have to do is find the x value for c. Well, I know that that whole side length must be a. And I know that that point B starts shifted over B. So my x value for C must be a plus B. Now let's look at our final example. The thing I know first, just by looking at this, I know that A must be 0, 0. I don't have any other information. So I'm going to decide that C is at A, 0. I'm setting A as an arbitrary number. Now, if this is a rhombus, then all of these points are equally spaced. So B must be at 0, A, and D must be at 0, negative A. And my side length of this rhombus would be a square root of 2, because what we've actually made are 4 45, 45, 90 triangles, where each leg is length A, so the hypotenuse would be a square root 2. Now let's talk about proving parallelograms to be rectangles. Okay, first we have to prove that a quadrilateral is a parallelogram before I can prove it's a rectangle. Then you can prove it's a rectangle using two methods. You can either prove that all four angles are 90 degrees, or you can prove that the diagonals are congruent. So let's look at some examples. Here I have a parallelogram ABCD with vertices A, B, C, and D. I've plotted those points. I'm going to label and connect them so I can see the shape. I want to show that this is a rectangle. But before I can do that, I have to prove it's a parallelogram. So I'm going to prove it using the opposite slopes method. I'm going to prove that the opposite sides are parallel, or that the opposite sides have the same slope. So I went through, I found the slope of each side. That's great. I have the slope of each side. I found that sides AD and BC both have a slope of 1, therefore they're parallel. And I also found that sides AB and CD have a slope of -1, so they're also parallel. Therefore, it's a parallelogram. Now, I can also stop right now and tell you that ABCD is also a rectangle because the adjacent sides are perpendicular. My adjacent sides have opposite reciprocal slopes. So that would be the end of my proof right there. I could do it another way, though. I could prove ABCD is a rectangle by proving that the diagonals are congruent. That means I'm going to need to use the distance formula. And I use the distance formula by using the 2 points. I found the length of segment DB, and I found the length of segment AC. I plug in the coordinates into the formula, and I get that both diagonals are 4 square root of 10. Therefore, ABCD is a rectangle because the diagonals are congruent. Now, proving a quadrilateral to be a square. This will be your least favorite thing in this whole lesson. In order to prove a quadrilateral to be a square, we have to first prove that the quadrilateral is a parallelogram by any of our methods. Then we have to prove that it's a rectangle by any of the methods. Then we have to prove it's a rhombus by any of the methods. You must prove all 3. If you don't prove all 3, you've not proven it to be a square. So let's practice. I have some kind of quadrilateral, ABCD. I know the vertices. I'm going to plot the points. I'm going to connect and label them. Now, I want to first prove that it's a parallelogram. I always do parallelogram first because the other 2 definitions depend on it being a parallelogram. I'm going to use the opposite sides are congruent method. Therefore, I'm going to use the distance formula 4 times to find the length of each side. I found the distance of AB using the distance formula, the distance of BC, distance of CD, and the distance of AD. And we're in luck because all of those sides are congruent. Because my opposite sides are congruent, ABCD is a parallelogram. That's great, but I can actually get more information out of this. Because all of the sides are congruent, ABCD must be a rhombus. So I've already proven 2 of my 3 things to get this thing to be a square. So let's go on. Now, I have proved ABCD is a parallelogram and a rhombus. I am now going to see if ABCD is also a rectangle.